Let's make a prediction for a real-world situation using a quadratic model. A helium balloon is released and floats up before coming back down to the ground. The following dataset shows the height in feet y of the balloon, corresponding to the number of minutes passed, x. How high will the balloon be after 4 minutes? To solve this problem, we will use Desmos to graph the dataset. To enter a dataset, click the plus sign at the top left of the screen and select Table. Select the first cell under X1 with the cursor. Type the values from the dataset into the table. Press Tab to progress to the next cell. Desmos will graph the coordinate points on the grid to the right as they are entered. 1, 99.7, 1.5, 130, 3, 149, 4.5, 172, 7, 108, 9, 84. You can see that each data point in the set has been entered. These distinct points represent moments from the balloon's flight. We will now find the curve of best fit. The equation that Desmos uses to find the curve of best fit is shown here. We will enter it into Desmos. Select the second function line with the cursor. Y. 1. Notice Desmos recognizes where the subscript text should be. To enter the tilde, we use the Shift button. This symbol means approximately. A, x, 1, the exponent symbol, 2, plus, b, x, 1, plus, c. Desmos automatically generates the curve of best fit. Look at the parameters that have appeared under the curve of best fit equation. These are the coefficients of the curve of best fit. Now we have our curve of best fit. This curve models the flight of the balloon. We can use it to find the height of the balloon after 4 minutes. This moment is represented by an x value of 4. Let's enter the line x equals 4 to determine where it intersects the curve of best fit. Move the cursor to the intersection of the line and the curve and select the point. The coordinates will appear. The y value is approximately 156.0, so we know that after 4 minutes, the balloon will be approximately 156.0 feet. This is our solution.